So when you're solving for these systems of linear equations, there's going to be two possible types of solutions. Two. Three possible types of solutions. I'm saying two because one of them you don't have any. But anyway, you can have one solution, okay? If it has one solution, one ordered pair, that means it's called an independent system, okay? If it has infinitely many solutions, meaning it can be negative infinity to infinity, you can pick any points in the world that you want, that's going to be called a dependent system. And then if you don't find any solution for the system, then it's going to be an inconsistent system, okay? So when you're looking for the solutions is going to be an ordered pair because this is a linear equation in two variables. So when you find that ordered pair, in order for it to be a solution, it has to make every equation in the system true, okay? And we'll walk through that together so you can see it. These are just some visual examples, and I use the Desmos online calculator to graph these. If you notice, this is an independent system. That means it has one solution. So this particular graph up here, that's the red, or sorry, this equation, that's the red, and then this equation is the green. So notice that they intersect each other at one point. That's the solution of this system. That means that the point 5, 1, if I substitute 5 for x and y for 1 here, I do get 3. And if I substitute 5 for x and 1 for y here, I do get 13. That means that 5, 1 makes both of these equations true. When you substitute the values back in, you get the answer that the constant that's after the equal sign. So this is what it would look like if you were graphing it. So now we're going to do all of ours by hand because I want to make sure that you see, you know what it looks like, the final answer, and you can know, okay, this is an independent system. This is a dependent system. This is an inconsistent system. I want you to be able to tell the difference, but I also want you to see graphically, you can tell immediately with graphs. This would be a dependent system. So if you look close, I know it's small, but you'll notice it's flipping from red to green. That's because the red is this first equation. And when I graph the second equation, it takes over. So they're literally the exact same equation. Yes, they look differently, but when you do the math and when we go through the different methods of solving, you're going to see sometimes the equations end up being exactly the same. And so that means it's going to have infinitely many solutions, which means that the graphs depend on one another. The equations depend on one another. You can't have one equation without the other. So that's how I kind of remember dependent system. So if you can remember independent, they intersect, dependent, they rely on each other. Okay, just like how it sounds. But that means every single point from here to negative infinity to here to positive infinity is a solution. That's what that means. It has infinitely many solutions, okay? An inconsistent system. The only thing you really have to remember, if there's no solutions, that means they do not cross each other and they do not overlap each other. They're going to be parallel to each other, whether they're going this way, whether they're going this way, or they're slanted like that. They're going to be parallel to each other. So they won't have any points in common. They won't have anything in common. That makes it no solution for this particular system. Okay, and it's inconsistent. Now, in order for a solution to work for a system member, remember, it has to work for every single equation. So if you have 3 equations, it can't just work for 2 of them. It has to work for all 3 of them, okay? So just remember that. It's not a matter of it working for 1 or 2. It needs to work for all of them, okay? So that's what they look like graphically.